Hi, I am Mohan Rush. I am from Sri College of Engineering. I am working as an assistant professor. So I welcome you all to the Sri Center of Excellence. So this is a robotics and advanced factory automation lab. So here I am going to explain the Mitsubishi FI learning setup. So in that Mitsubishi FI learning setup, we have a PLC and one VFD, and we have a 3-axis servo drive. So here I am going to demonstrate the working of an induction motor and how the induction motor speed can be changed by using that VFD. And also I would like to give one small demonstration about the 3-axis servo drive. So first I would like to explain that VFD. So we know very well, so what is that VFD? That VFD is nothing but it is a variable frequency drive. From the name itself we can identify that by varying the frequency we can control the speed of the induction motor. We are all very familiar with that formula. We know that Ns is equal to 120 F by P. That speed is a function of the frequency. So this VFD, it is a Mitsubishi A800 series VFD. It is a 0.5 HP drive. So in that by using that VFD we can control the motor, that is it completely take care of the motor from the starting, braking and speed control, that everything is possible by using that VFD. So in that VFD it is a single input, that is single phase input. 230 volt is an input voltage, that 50 hertz. Then the output is a 3-phase output. The voltage range is 230 volt, 0 to 230 volt, and the frequency is 0 to 50 hertz. You can control the frequency above 50 hertz. That is also possible by using this VFD. So in that VFD I am going to control the speed of that particular induction motor. The induction motor is there. It is a 0.5 HP induction machine, 3-phase induction motor. So before we do the speed control, we need to wire that particular VFD. That wiring, we have two type of wiring. One is a power wiring, another one is a control wiring. That single phase input, that is directly goes to the VFD. The 3-phase output is taken from the terminal UVW, which is that wires RYB, which is connected to the induction motor. So this is a power cable. So this is a power wiring setup. And one more thing, we need to do the control wiring. So these are the control terminals available in the VFD. So example, here you can see that it is STF. STF means it is a start forward. STR means start reverse, stop, high speed, middle speed, low speed, jog. Then all the operations are possible by using this control terminal. So here I am not going to use the control terminal to control the speed of that induction motor. So 3 ways you can control that induction motor speed. The first way is that by using that control terminals and potentiometer you can vary the speed. The second thing is that by using that PLC you can send that analog signal. Through the analog signal you can control the speed of your induction motor. The third thing is that by doing such kind of so by programming in that part, by using that part of PU means it is a programming unit, that is it is like a keypad now. So by using that keypad we can control that induction motor. So this is a demonstration. So I am going to show the going to control the speed of an induction motor using this keypad. So here I am not going to do any wiring, only I am going to control the speed by using that keypad. So here in that keypad we have PU, programming unit. Then external means by using the PLC or some other external medium I can control the speed. The third is the network. So now I am going to control that through PU. It is a programming unit. So these are the modes possible: monitoring mode, parameter mode and program run mode. So this drive is for a induction motor and permanent magnet synchronous motor. Now I am going to use it for induction motor. So that LED glows in induction motor. So by pressing this button you can change or you can navigate from PU mode to external mode and external mode to PU mode. So this is our mode of operation, monitoring and parameter. So before we do the speed control we need to set the certain parameters in the VFD. So that this VFD has more than 1000 parameters. You no need to set the more than 1000 no need to set all the parameters. So in that 1200 parameters, please at least set 1 or 2 5 parameters, 10 parameters regarding. It means that you are putting information about that motor. So for example, so by using this part, so with the parameter 1 is a torque boost. Similarly, parameter 2, minimum frequency. Parameter 3, maximum frequency. Parameter 4, it is a base frequency. Parameter 5, acceleration time, deceleration time. So like that you need to set all the parameters by using the keypad. Once the parameter setting is done, again navigate to monitoring mode. Now the drive is ready. We have configured the drive. So when I press that forward button, now I setting the frequency is 3.51 Hertz. So it is a very low frequency. We know, as we know, that speed is a function of frequency. So the motor is running at low RPM. So this is the speed of your induction motor for 3.5 Hertz. Suppose if I increase the frequency by using this part, I am going to increase the frequency to 15.2 Hertz, 15 Hertz. I am setting the frequency to 15 Hertz. So if it is 50 Hertz, the machine will run at least some 500 RPM or 200 RPM. So now the speed is increased because of increasing frequency. So if I further increase the frequency, I am going to increase the frequency to 50 Hertz. 50 Hertz is the rated frequency. So I am going to drive the motor at rated speed. Now I am increasing the frequency to 50 Hertz. Now it is 50 Hertz. If I set then the motor speed will keep on increasing and it finally reaches the no load speed. Because the machine is running under no load, so that speed of the machine, it will be very close to synchronous speed, exactly at 1500 RPM. So you can monitor in the parameter we have many parameters are there. So in certain parameters are comes under monitoring category, another parameters are comes under that troubleshooting category. So you can monitor the speed of the induction motor and also current, then torque, then everything can be monitored in that VFD.
Great. Thank you.
Thank you.